Piping systems are logical entities that facilitate calculations for flow and sizing of piping. Piping systems can be created in two ways. One way is to add pipe to connect the waterside components, and they will automatically be added to a piping system. The other way is to select the components and manually add them to a system. Then you can have Revit generate and lay out the piping. Take a look at how to manually create a piping system. A piping system consists of one or several target connectors and one source connector. However, you do not have to specify the source connector. For example, you would think that a source connector in a piping system would be a pump. But in this design, each water source heat pump has an integrated pump, and you can only have one source connector. So you can specify the cooling tower as the source connector, since the cooling tower must handle the load of each water source heat pump. Create two piping systems, a condenser water supply and a condenser water return system. Each water source heat pump has a supply and return connector. Those connectors will be the target connectors, and the supply and return connectors on the cooling tower will be the source connectors. To create a piping system, first select a water source heat pump. When you do, the ribbon changes to the Modify Mechanical Equipment contextual ribbon. On the Create Systems panel, click Piping. Revit displays the Create Piping System dialog. Here, you can select the system type and give the system a name. By default, there are several system types for pipe, such as domestic, fire protection, hydronic, sanitary, and vent. However, you can create custom system types to handle the needs of the waterside systems in your project. When you expand the system type drop-down, you can see the available system types that this heat pump can belong to. The system types appear because there are pipe connectors placed on the equipment family that are assigned a system classification. Choose Hydronic Supply. You can also select whether or not to open the system in the System Editor. Leave this checkbox cleared and name the system CWS for Condenser Water Supply. Then click OK. When you do, the system is created, but only one heat pump is added to the system at this point. In the contextual ribbon, click Edit System. Revit enters into Edit Piping System mode, and everything on the screen goes dim except for the components in the piping system. Also, Add to System is selected by default in the Edit Piping System panel of the contextual ribbon. So you can begin selecting components with target connectors to add to the system. As you can see, each time you select a water source heat pump, the element becomes bold, and you can easily see which components you have selected. If you select a component by mistake, select Remove From System in the contextual ribbon, and then select a component to remove. You can also use a window selection to select multiple components at once. Once all the target components have been selected, you can select the source component by clicking Select Equipment in the Edit Piping System panel of the contextual ribbon. With this tool active, select the cooling tower. Pay attention to what happens when you select the cooling tower. A Select Connector dialog appears. This is because there are multiple hydronic supply pipe connectors placed on this family. You can only use one connector on a single piece of equipment per piping system, whether it is a target or source connector. Select the first one and then click OK. At this point, you can no longer select the cooling tower to add the other hydronic supply connector. This is not a problem though. You can still connect pipe from this system to it later. With the equipment selected, the System Equipment drop-down in the Options bar displays the mechanical equipment element that you just selected. With all the components selected, click Finish Editing System. Now when you select one of the heat pumps that belong to the piping system, two contextual ribbons display. Looking in the Properties palette, you can see the system name under Mechanical. If you had several piping systems created, you may forget what equipment is part of which system. Switch to the Piping Systems contextual ribbon. Now the Properties palette populates with the system properties. On the contextual ribbon, in the System Tools panel, you can see the system name in the System selector. Also, if you want to edit the system, you can click Edit System to return to Edit Piping System mode. Additionally, if you had not selected the source connector or equipment for the system, you could click Select Equipment Now in order to do so. And if you wanted to disconnect the equipment from the system, you could click Disconnect Equipment. Click Edit Type in the Properties palette. Revit displays the Type Properties dialog for the piping system. The type is currently set to Hydronic Supply. If you want to create additional types, you could click Duplicate. Then you can change parameters for that system type, such as graphic overrides, material, calculations, fluid type, and several rise-drop parameters. For example, for hydronic supply systems, you may have chilled water supply and condenser water supply systems that you want to display differently. Click Cancel to close the dialog. In order to see each system in the project, you can look in the System browser. To open the System browser, switch to the View ribbon. In the Windows panel, expand the User Interface button and select System Browser. This opens the System browser, which is organized in a tree structure. Currently, the view is set to Systems and All Disciplines. However, you could change this to Zones or filter the view by a discipline. In the Unassigned branch, you can see that there are several items that have not been assigned to a system. You could continue expanding the branches in order to see the specific items. When an element is placed in the model with some type of connector, it is organized in the System browser under Unassigned, depending on the type of connector. Then once it has been added to a system, it is organized based on the type of system. For example, when you expand the Piping branch, you can then expand the Hydronic Supply branch and see the equipment for the system you just created. When you expand that branch, the system name appears. When you expand the system, each target component appears. The flow and size for each item are also displayed. Realize that when you highlight an element in the tree, it is highlighted in the model. Also, when you select one of these components in the tree, several other branches highlight. This is because the equipment has several other connectors that fall under one of the other categories. Since this is a water source heat pump, there are obviously additional water connections under piping, and the equipment will need power, so there is a power connector under electrical. Additionally, there is a supply and return air connector that is not part of a system. So as you can see, creating systems can become very complex. They should be used for your benefit. However, you do not have to create a system for every single connector. But be aware that when you connect these items together, a system will automatically be created. Now create the condenser water return system. Select a water source heat pump. Next, on the Create Systems panel, click Piping. Revit displays the Create Piping System dialog. Choose Hydronic Return for the system type and then name the system CWR for Condenser Water Return. Next, select Open in System Editor and then click OK. When you do, Revit enters into Edit Piping System mode. Select all the water source heat pumps. Since each one Piping systems are. Choose hydronic return for the system type and then name the system CWR for condenser water return. Next, select Open in System Editor and then click OK. When you do, Revit enters into Edit Piping System mode. Select all the water source heat pumps. Since each one has a hydronic return connector as well, they are added to this system. With all the target connectors selected, click Select Equipment and select the cooling tower again. Finally, click Finish Editing System to create the piping system. Piping systems can be created in two ways. One way is to add pipe to connect the waterside components, and they will automatically be added to a piping system. The other way is to select the components and manually add them to a system. Then you can have Revit generate and lay out the piping. However, with several components in a system, it is difficult to get the results you are looking for. In this model, two piping systems have already been created: condenser water supply and condenser water return. Take a look at how Revit generates piping layouts. Select the cooling tower. When you do, a piping system contextual ribbon appears next to the mechanical equipment contextual ribbon. Switch to the piping systems contextual ribbon. Now a dashed line appears around all the components in the piping system. In the contextual ribbon, you can see the name of the piping system in the system selector. Switch back to the Modify Mechanical Equipment contextual ribbon. Pay attention to the tools in the Layout panel: Generate Layout, Generate Placeholder, and Connect Into. The Generate Layout tool provides different layout solutions to add selected equipment and components to a piping system. The Generate Placeholder tool is pretty much the same, except that it uses pipe placeholders instead of pipe elements. Lastly, Connect Into creates a physical connection between a selected component and a pipe. Click Generate Layout. Revit displays the Select a System dialog. Since the cooling tower belongs to two piping systems, you can select which system you want to generate a layout for. Select the Condenser Water Return System, CWR, and then click OK. When you do, Revit goes into Generate Layout mode. Within a few seconds, several solutions are provided. In the Options bar, you can expand the Solution Type drop-down to choose one of the solution types: Network, Perimeter, or Intersection. There are various layouts for each type. For piping systems, Perimeter or Intersection is typically the best. For this example, choose Perimeter. For this solution type, there are multiple layouts. You can use the Next Solution and Previous Solution buttons to view the various layouts. Use the fourth solution. Also, if you have not specified the pipe conversion settings in the Mechanical Settings dialog, you can do so now by clicking Settings. This opens the Pipe Conversion Settings dialog. As you can see, these settings are for the hydronic return system type. You can control all the settings in the Mechanical Settings dialog. Ensure that the pipe type is set to carbon steel for both the main and branch settings. Then click OK to close the dialog. If you do not see a solution that you like, you can click Edit Layout in the contextual ribbon. Then you can select and move any of the main and branch pipe route paths. You can also select Remove From System to remove any of the components from the system layout, or Add to System to add a component back into the system. Once you are satisfied with the layout solution, you can click Finish Layout and Revit will generate the layout. Once the layout is generated, several warnings appear. Since there are multiple components in this system with pipe connectors at varying elevations, Revit has trouble generating an accurate layout. However, you may wish to start with this and modify the layout that Revit has generated. Click anywhere to dismiss the warnings and then click Undo until the pipe is removed. Sometimes with piping systems, it is easiest to manually lay out the system. Start by selecting the cooling tower. With the component selected, pay attention to the icons at each pipe connection. You can see an icon indicating the connector type, as well as the size and whether the flow is in or out. When you hover the cursor over an icon, the tooltip reads Create Pipe. Click the top hydronic icon. When you do, a Select Connector dialog appears. This is because there are two connectors at the same location in plan view, but they are at different elevations. Select the hydronic supply connector and then click OK. Once you do, the pipe tool is active and the starting point of the pipe segment has already been placed at the connector you just selected. Now you can create the main pipe segments. Move the cursor to the left and click to place a horizontal segment. Next, change the offset in the options bar to 10 feet 6 inches, or 3,200 millimeters in the metric file. Then move the cursor to the left past grid 2 and click to place another segment. Now move the cursor down past grid H, click to place another pipe segment, and finally move the cursor to the right and create a final main pipe segment. Click Modify to end the command. For this example, you use the same pipe diameter to create the entire main supply pipe. At this point, you can size the pipe after the branches are connected. However, you could create several pipe segments along the path and change the size as you go. The next step to laying out this piping system is to connect each water source heat pump to the main pipe. Zoom out and pan up to the north side of the building. Start with the first water source heat pump along the path of the pipe. When you select this water source heat pump, pay attention to the connector icons. Once again, you can see a hydronic icon, and when you click this icon, the Select Connector dialog appears. This is because the hydronic supply and return connectors are at the same plan location on the equipment, just at different elevations. Since you are laying out the condenser water supply system, select the hydronic supply connector and click OK. Now you are creating a pipe segment for that connector. Create a horizontal segment and then click the main pipe to place a vertical segment. When you do, Revit connects the vertical segment to the main pipe segment by placing the appropriate fittings, and it places another pipe segment perpendicular to the work plane. This is because Automatically Connect is selected in the Placement Tools panel of the contextual ribbon. The pipe tool is still active, so click Modify to end the command. You can also use the Connect Into tool to do the exact same thing you just did. Select the next water source heat pump. Then select Connect Into in the contextual ribbon. Revit displays the Select Connector dialog. Once again, select the hydronic supply connector and click OK. Now you must select the pipe to connect into, so select the main pipe. When you do, pipe segments and fittings are created to connect the hydronic supply connector on the water source heat pump to the main pipe. At this point, you can select the vertical segment and move it as necessary. The other segments will remain connected to the vertical segment when it is moved. Switch to the 3D piping plan view to take a look at the results. There are a few different methods to sizing piping in Revit. You can simply change the size of each pipe segment as you sketch pipes, or you can size the piping after it has been created. In this model, there are two piping systems that already have piping laid out. However, the piping has not been sized. The condenser water supply system is displayed with blue, and the condenser water return system is displayed with red. In this exercise, compare automatic pipe sizing to manual pipe sizing. Zoom into the north portion of the building. When designing, you may wish to create working views in which you place tags with certain information to help design, and plotting views with tags that you need for documentation. For example, when sizing pipe, it is useful to have the flow to each piece of equipment readily available. You may have a table listing the water flow to each heat pump. You could also place a tag on the mechanical equipment listing its flow. In this case, you can select a pipe segment to see flow information or select a heat pump to see how much water flow it needs. For example, when you select Water Source Heat Pump 1-14 in the Properties palette under Mechanical, you can see the water flow. When you select a pipe segment, you can see the flow information in the Properties palette under Mechanical Flow, such as the flow, Reynolds number, flow state, and velocity. Begin by sizing some of the condenser water return segments. Select the horizontal pipe segment connected to the cooling tower. Looking in the Properties palette, you can see that the flow is 168 GPM, or 10.64 liters per second in the metric file. There are also a few methods to sizing piping in general, such as by flow, friction, velocity, or some combination of these. There are several charts, tables, and sliders that are used to size pipe. Use a standard pipe sizing chart for this example. Also, use a head loss or friction method at 2.5 feet of water per 100 feet for imperial units, and 245 pascals per meter for metric units. Make sure the fluid velocity in the pipe does not exceed 4 feet per second for imperial units and 1.2 meters per second for metric units. For the pipe segment with 168 GPM, or 10.64 liters per second in the metric file, it appears that the pipe diameter should be 4 inches, or 100 millimeters in the metric file. This is actually the diameter at which the pipe was created. However, if you need to change the diameter, you can do so by changing it in the Options bar or Properties palette. Also, if you need to select all of the pipe segments and fittings up to the next branch in order to change the diameter, press Tab to highlight that portion of the system, and then select the elements. Realize that you can change the diameter of both pipe segments and fittings when they are selected. Move over to another portion of the system. Pan over to the long vertical pipe segment in the corridor. With this pipe selected, you can see that the flow is 108 GPM, or 6.84 liters per second in the metric file. Looking at a pipe sizing chart, it appears that the pipe diameter should be 3.5 inches, or 90 millimeters in the metric file. Do not change the diameter though. Use the pipe sizing tool to see how Revit sizes the pipe. Click in blank space to deselect the pipe and then zoom out. With the pipe sizing tool, you can size multiple pipes in different systems at once. To select all the pipes in both the condenser water supply and condenser water return systems, hover the cursor over the cooling tower, press Tab 3 times to highlight all the pipes, and then select them. When you do, the ribbon changes to a multi-select contextual ribbon, and there are several options. In the Analysis panel, click Duct Pipe Sizing. Revit displays the pipe sizing dialog since you have pipe selected. You can use the tools in this dialog to choose how you want Revit to size the pipe. Also, realize that Revit will use the sizes specified in the mechanical settings to size the pipe. So if there are certain sizes that you do not use when sizing pipe, you will want to turn those off. There are actually two areas in this dialog: Sizing Method and Constraints. Under Sizing Method, you can expand the drop-down and select the method you want to use. The available options are friction and velocity. Choose friction. Then in the field next to it, set the friction to 2.5 feet per 100 feet, or 245 pascals per meter in the metric file. Also, the radio buttons below the Sizing Method drop-down are available. With friction selected, you can choose "and" to use both the friction and velocity methods when sizing the piping. You could also select "or" to use both methods. However, with "or" selected, the size of the pipe is allowed to break either the friction or velocity rule, but must comply with one. Since you used both to manually size the pipe, select the "and" radio button. Then set the velocity to 4 feet per second, or 1.2 meters per second in the metric file. In the Constraints area, you can expand the branch sizing drop-down and choose Calculated Size Only, Match Connector Size, or Larger of Connector and Calculated. Select Match Connector Size. Below the drop-down, you can choose to restrict size, but do not select this option for this exercise. With all the desired options selected, click OK to let Revit size the piping. Once Revit has calculated the pipe sizes, you can select each pipe segment and compare the size to the previous results. Once you have designed and laid out piping systems, you can analyze those systems in several ways. Take a look at a few methods. In this project, there are two piping systems, condenser water supply and condenser water return. They are displayed with blue and red respectively. When you select a pipe in a piping system, there is an analysis panel that appears on the Modify Pipes contextual ribbon. One of the tools available is the System Inspector. Click System Inspector to activate the tool. When you do, a System Inspector panel appears in the drawing area. You can move this panel as needed. The Properties palette also populates with the parameters for the piping system. At this point, the piping system is essentially isolated. Everything else in the drawing area is dim. You can only modify elements in the piping system. To begin inspecting the system, click Inspect. Once you do, arrows appear in the system indicating the direction of the flow. The worst case path in terms of pressure is shown with red arrows. Also, an icon appears next to the cursor indicating that Revit is in inspecting mode. Now when you move the cursor over any of the elements in the system, that section or subsection in the system highlights. A tag also appears showing the flow, static pressure, and pressure loss information in that section. When you highlight a terminal section, you can also see the total pressure and excess pressure. The excess pressure is determined from the pressure in the terminal section compared to the pressure in the worst-case path. When you click any section when the tag appears, the tag will temporarily be placed in that location. You can continue to move your cursor over other sections and another tag will appear so that you can compare the sections. But when you click to place the tag in a new location, the previous one disappears. Only one tag can be placed at once. Once you are finished inspecting the system, click Finish in the System Inspector panel. When you do, the flow arrows no longer appear, and any tag that was placed is removed. Another way to analyze a system is to create a pipe legend. To create a pipe legend, on the Analyze ribbon, in the Color Fill panel, click Pipe Legend. Note that the Color Fill panel also appears on the Annotate ribbon. Once you activate the tool, a legend appears under the cursor, and you can click to place the legend. Next, select the legend that you just placed in the drawing area. In the Contextual ribbon, click Edit Scheme. Revit displays the Edit Color Scheme dialog. There are three areas in this dialog: Schemes, Scheme Definition, and Options. Under Options, the option Include Elements from Linked Files and Fill options are available. In the Schemes area, Pipes is the only category available in the category dropdown. There is also one scheme already created. When you select a scheme in the list, you can then see the scheme definition. Take a look at the size scheme. As you can see, there are several size values in the value column. Each one of these is marked as visible and has a specific color and fill pattern assigned. If you use this scheme, you can quickly see where the smaller and larger pipes are by looking at the colors of the pipe. Create a scheme to check the velocity in the pipes. In the Schemes area, click Duplicate. In the Name Color Scheme dialog, name the scheme Pipe Color Fill -Velocity, and then click OK. Next, you need to change the parameter in the color drop-down. Expand the drop-down. Be aware that there are several options to use when creating a color scheme, such as friction, pressure drop, slope, and so on. When you select velocity, Revit displays a dialog informing you that colors are not preserved when changing which parameter is colored. Since this is what you want to do, click OK. Also, you can use a range instead of a value. This is controlled by the radio buttons above the table. When you select By Range, only 2 rows appear in the table. Now you can use this scheme to ensure that there are not any pipes with the fluid velocity too high. To do this, change the At Least value in the second row to 5 feet per second, or 1.4 meters per second in the metric file, to have a little leniency, and then click Apply. Next, click in the Color field on the second row to open the Colors dialog. Change the color to red, and then click OK. Now any pipes with a velocity greater than what you want will highlight in red. Also, change the color in the first row to green to indicate that the velocity is good. Then click OK to apply the color scheme and close the dialog. Back in the drawing area, everything looks good and it appears the system was designed properly. Remember that you can use several parameters to analyze a design by applying a pipe color scheme. Just to see if a pipe would indeed turn red if the velocity was too high, select a heat pump and change the water flow to 100 GPM, or 6.3 liters per second in the metric file. Once you do, you can see that some of the pipes upstream turn red. Using pipe color schemes is a great way to analyze piping systems. Whenever you are creating piping systems, you can use the Check Pipe Systems tool and the Show Disconnects tool to ensure that the system is being modeled properly. Since the results can be overwhelming when a piping system is not completely modeled, start with a simple example. On the Systems ribbon, in the Plumbing and Piping panel, click Pipe. Move the cursor into the drawing area, click to place the pipe start point, then move the cursor to the right approximately 10 feet or 3,000 millimeters in the metric file, and then click to place the end point. The exact distance is not critical for this example. Next, move the cursor down about 10 feet or 3,000 millimeters and click to place the end point of the next pipe segment. Then click Modify to end the command. The Check Systems tools are available on the Analyze ribbon in the Check Systems panel. The Check Pipe Systems tool verifies that all piping systems are properly connected and also checks for valid system assignments. Remember that each pipe created is automatically added to a piping system, and whenever you connect components with piping, they are assigned to that system. To begin, click Check Pipe Systems. When you do, a warning icon appears in the drawing area, and a dashed line connects each open end of the pipe. When you hover the cursor over the warning icon, a tooltip appears that states Show Related Warnings for MEP Systems. Click the icon. Revit then displays a warning. This warning states that it is not possible to calculate the flow since the flow direction is mismatched. This is due to the fact that there are two open connections. Click in blank space to dismiss the warning. In order to quit checking the systems, you can click Check Pipe Systems to toggle it off. Now click Show Disconnects in the Check Systems panel of the Analyze ribbon. This time, Revit displays a Show Disconnects Options dialog. Here, you can select which category of elements that you want to see disconnects in. Select Pipe and then click OK. Back in the drawing area, a warning icon appears at each open end of the pipe. You already knew that each end was open, but now an icon indicates the open ends. The tooltip for each icon simply states that the element has an open connector. When you have a more complex system, it is much harder to spot disconnects or any problems that may be in the system. You can click a warning icon to display a warning stating the same thing. When you do, the pipe with an open connector also highlights. Click in a blank area to dismiss the warning. Next, zoom into the elbow and select one of the pipes connected to the elbow. Slightly move the pipe connector so that it disconnects from the elbow. Now when you zoom out, it appears that the pipe is still connected. If there were several piping systems with mechanical equipment, piping, and other components, this would be hard to see. But Revit has already added a warning icon to indicate a disconnect. To remove the warning icon, simply reconnect the pipe to the elbow. As you can see, the Check Piping Systems and Show Disconnects tools can be very helpful in finding problems in the piping system. If you no longer want to see the disconnects, you can click Show Disconnects on the ribbon, clear the category, and then click OK. During the design process, you may wish to create a pipe pressure loss report to analyze your piping systems. To create a pipe pressure loss report, on the Analyze ribbon, in the Reports and Schedules panel, click Pipe Pressure Loss Report. Revit displays the Pipe Pressure Loss Report System Selector dialog. Here, you can select which piping systems you want to create a report for. A report will be generated for each system that is checked. You can use the buttons at the bottom to select all, select none, or invert selection. Or you can click the System Type Filter button to filter the system by system type, such as domestic cold water, domestic hot water, hydronic return, or hydronic supply. Click Cancel to close this dialog since there are only 2 systems in the current project. With both checked, click OK. Then Revit displays the Pipe Pressure Loss Report Settings dialog. On the left, you can see a list of available fields that can be added to the report. On the right is the list of report fields. There are already several parameters added to the report fields list. Also note that the order of the list affects the order in which these parameters will display in the report. If you want to add additional parameters, select the parameter in the available fields list and click Add. You can use Ctrl and Shift to select multiple parameters at once. To remove a parameter from the report fields list, select it and click Remove. You can control the order of the parameters in the list by using the Move Up and Move Down buttons. Additionally, there are several options at the bottom. You can choose whether or not to display system information, display the critical path, display duct or pipe pressure loss by section, display fitting and accessory pressure loss by section, and open the pressure loss report directly after created. Leave each one of these settings selected for this example. Realize that there are also fields buttons next to 2 of the settings. Click the first one to display the Straight Segment Settings dialog. Here, you can control the parameters that will be used in the report for straight pipe segments. Once again, there is an available fields list and a report fields list. You can add and remove parameters just like you can in the previous dialog. Click OK to close the dialog. The Next Fields button opens the Fitting and Accessory Loss Settings dialog. Once again, you can control which parameters are added to the report. Click OK to close this dialog. Once all of the available settings are specified, you can create a report format by clicking Save at the top. Then you can quickly use these same settings later by selecting the format from the Report Format drop-down. Click Save. In the Format Name field, type Pipe Pressure Loss Report, and then click OK. Finally, to create the report, click Generate. Revit then displays the Save As dialog, and you can navigate to the folder where you want to save the report and give the file a name. Also, pay attention to the Save As Type drop-down. You can choose to save the report as an HTML file or CSV file. Choose HTML and then name the file Pipe Pressure Loss Report. Once you specify the file name, click Save. Revit then begins to generate the report. Once it is complete, the report opens. At the top, you can see the report name along with project information. Below that, you can see the name of the first piping system. The first table lists the system information. Moving down the report, you can see the total pressure loss calculations by sections. Each parameter that appeared in the report fields list is now a column header. Also, at the bottom of the table, you can see the critical path and total pressure loss in the system. Continuing on, the next table is the detail information of straight segment by sections, and the last table is the fitting and accessory loss coefficient summary by sections. After that, the same tables appear for the other piping systems. As you can see, the Pipe Pressure Loss Report contains some valuable information that can help you analyze your piping systems. In order to properly document your design, you need to ensure that every component in the design is properly scheduled and tagged. Also, most tags indicate a mark, which can be used to reference that component in a schedule. In Revit, this is very useful because a parameter that is used in a schedule and a tag will be the same in both locations. If you change the parameter in the schedule, it would update in the tag as well. To begin tagging elements, switch to the Annotate ribbon, and on the Tag panel, click Tag by Category. The ribbon changes to the Modify Tag Contextual ribbon. You can then move into the drawing area and begin tagging elements. When you hover the cursor over an element, you can see a preview of the tag. To place the tag, simply click. The controls in the options bar control whether the tag will be placed horizontally or vertically. You can also select whether or not to include a leader. With leader selected, you can choose attached end or free end to control the end of the leader line. You can also specify the length of the leader line if attached end is selected. The Tags button opens the Loaded Tags and Symbols dialog. In this dialog, you can see which tags will be used for the various categories of elements. You can also specify a new tag to use by selecting from the loaded tags for each category. If a tag you want to use is not available, click Load Family in order to load the tag. Click Cancel to close the dialog. Deselect Leader and begin tagging the pipe. As you can see, there are two piping systems here, condenser water supply and condenser water return. In Revit, the systems are displayed with different colors, but when this view is plotted, you would have to print in color to show the different systems. A better option is to add additional detail to your pipe size tags. Click Modify to end the command. Select a pipe size tag and then click Edit Family in the contextual ribbon. Once you do, the family opens in the Family Editor. In the drawing area, select the text. Realize that this is actually a label, as can be seen in the contextual ribbon. Click Edit Label in the contextual ribbon to open the Edit Label dialog. Here, you can select any of the available category parameters to use in the tag. To add a new parameter, click Add Parameter under the Category Parameters list. As you can see, the parameter type must be a shared parameter. Shared parameters are stored in an external text file and can be referenced by both family and project files. It is important to have a company shared parameter file with all of the parameters that will be needed for schedules and tags. Only one shared parameter file can be used in a project or family file. Click Cancel to close this dialog. In this example, you can add additional detail to the pipe size tag by adding the system name. You could also add information such as the flow or velocity. In the Category Parameters list, select System Name. Then click Add Parameter to Label. In the Sample Value field for System Name, type CWX, since the system names are typically indicated by 3 letters. Then click OK to close the dialog. Now when this tag is loaded into the project, the label will reference the size and system name of the element. If needed, you could add additional parameters to the label. Next, in the ribbon, click Load into Project. In the Family Already Exists dialog, select Overwrite the existing version. Back in the project, the new tag is loaded, and you can see the system name after the pipe size. This helps indicate which system is which. If you wish to change or remove the pipe size suffix, you can do so in the Mechanical Settings dialog.